Hello fantastic people, I hope you are doing great. So today we'll create this amazing building system. So it has quite a lot of features. So of course you have different types of buildings, which are scriptable objects. So you create them using inspector. Then we have two different types of buildings. First ones are just simply tilemap based, right? So those are regular tiles on the grid. They are sorting correctly, so we are learning a lot about sprite sorting and tilemap sorting as well. So this is the first type of building. Then of course we can destroy whatever we placed as well. And then we have also something very exciting, which are buildings using tile rules. So you can also, you see, create just one, you have one tile, one building, one scriptable object for it, and then it behaves very nicely. So you can build fences, roads and stuff like that. Then we also have third type of items, or rather I should say second, because those two are just regular tiles on the tile map. But this mannequin is a game object, so it's regular game object. So it could have thousands of custom scripts, characteristics, interactability, and so on. But it behaves like it would be regular part of the grid, you see. So the important thing is it has this is probably the most complex part in the tutorial. It has a custom space. So you see those tiles occupy one single cell, but this one occupies two. And this is based on the RectInt. So you can literally say that you would like, for example, a building to occupy, I don't know, 4x4 square, and this will work correctly. Of course, removing those items works all right too. So you are able to place and destroy objects. Also over here on the top you see we have this simple UI which indicates the current object we are using or placing. And of course I couldn't mention that this video wouldn't exist if Naya wouldn't create her amazing game Maximus Jones for our community game jam. So this video is actually a reward for winning that jam. So once again, congratulations Naya, and I hope the video was worth waiting and participating in the game jam. Okay, just wanted to mention that the code from this tutorial, together with a lot of other stuff, will be available on my Patreon. So if you would like to show me some support, please feel invited to go to patreon.com/ptit. In case you would prefer to support me non-financially, this is also very important and very helpful. I would really appreciate if you could like this video, write a comment, subscribe to my channel, and maybe if you really think this video is worth something, just share it with your friends or colleagues with similar hobbies. So let's get started. Part of the buildings we'll be placing will be tilemap based. So let's create first tilemap. I'm going to the object, tilemap rectangular, and call it construction layer. As soon as I highlighted this one, you see there is this small new icon, so we can click on that and this will open for us the tile palette. So now we don't have any palettes at this point, so I'm clicking the create new palette, calling it the Buildables, pressing create, and I will create for that new folder. I'm going to call it tilemap, and then inside of it I'm going to create another folder called Buildables and select folder. Awesome. Now I can drag and drop sprites to turn them into the tiles. So I'm going to sprites. Over here I have my sprite sheet with different sprites for buildables, and I'm going to drag and drop this simple path over here. And again I'm going to navigate to the tilemap, buildables, and let's call it stone path. Save. Awesome. And straight away we have a tile that we can paint with. So I grab it and you see I can paint it everywhere. When we build something, it will be generally a little bit more than just simple tile, right? We would like to store some more information like its name, probably it will have underlying game object with some properties, maybe interactivity and so on. So in order to help us with that, let's create a scriptable object. I'm going to my scripts folder and then creating another one that I will call building system. Then inside of that folder, I'm creating a script and calling it buildable item. I'm double clicking on it and doing a little bit of cleanup. So first I want to change the mono behavior to scriptable object. Awesome. Then I'm also moving the buildable item to the building system namespace. Awesome. That removed the unnecessary using statements, and I'm also getting rid of those methods because we won't be using them. It turns out we can serialize properties now, so thank you so much guys for letting me know about that. Basically what we have to do, we have our typical serialized field attribute, but then in front of it we have to add field and colon. And now we can not only do like public string name, right? This works fine too, but we can also do name and then get, and for example private set. So this way we have a property that we can set only within the class, and then we can get it anywhere we want. So this is amazing. Okay, so we have one property for our name. Let's create another one for the tilebase. So basically tilebase is the actual file that is created when we create a tile on the tilemap palette. So we are able to actually store it as well in a field or property. So this is pretty neat thing. So public tilebase, and let's call it the building tile. Or maybe, you know what, let's call it just tile. Get private set. And now the tilebase lives in the tilemap's namespace, so we have to be using that too. Awesome. Now, in order to be able to create instance of this scriptable object, we have to add create asset menu attribute. And let's give it file name of the new buildable item. So this is how the new file will be created once we create it. And then let's also give it the menu name, which will be building and the new buildable item. Okay, so let's go back to Unity. In the root folder, let's create another folder and let's call it scriptables. Inside of it, let's create another one called buildable items. Awesome. And now let's create our first buildable item by going to create, building, and new buildable item. So basically this is what the create asset menu attribute allows us to do. It's literally adding the this path in the menu over here. So let's create that and let's call it the stone path. Awesome. Let's just give it a nice readable name with the space, stone path. And then as a tile, let's select our stone path tile. Okay, so let's create now a script that will allow us to build the buildings. I'm inside the building system folder and I'm creating new C# script. I will call it Tilemap layer. And basically this script will be a base for more complicated scripts. Basically what it will help us to do, it will hold the reference to the tilemap, so we don't have to do it. We don't have to grab the tilemap in each tilemap layer separately. You will see what I mean in a second. So I'm starting by moving it to the building system namespace. Then I'm creating protected tilemap property, public getter, protected getter and private setter. Awesome. I need to import the missing references. That's done. And now I'm creating protected void awake method, in which I'm grabbing the tilemap and storing it in our property. Then I'm also adding the require component type of tilemap. So this will ensure that the class that we drop the script on will have the tilemap component. So this is very important. And now whenever we extend the tilemap layer, we'll have this variable or this property available for us straight away. We won't have to add this part in every single class that will need it. So this is pretty convenient. And that means we can now create a construction layer, for example. So C# script, construction layer. Let's open it. Once again, moving to the namespace, removing the methods. And you see I'm not having here anything, I'm just changing the mono behavior to the tilemap layer. And now if I have any method, so for example, build, whatever, I can access the tilemap property because it is on the base class, and this is pretty convenient. Okay, so let's turn it into something useful. So let's make it public. And of course, when we want to build something, we want to build it at certain position. So let's have a coordinates here, world coordinates. And then of course, we will know which buildable item we want to build, right? So let's have that over here. And now we have world coordinates, but they are not the same as the positions in Tilemap. So we have to convert those ones to the ones that the Tilemap can understand and use. So for that, we can use very easy method, which is actually part of the Tilemap. So let's create a variable to store the result, and now tilemap dot, and now world to cell. And now we can just provide it the world coordinates. Done. So this can be easily used to set something on the tilemap. So let's do exactly that. So if our item has a tile, so it's not null, then let's set the tile, add that coordinates, and which tile we want to use, of course, item.tile. And this will be enough to give us the first easiest way to build something. Okay, so we are able to build something on our construction layer, but now we have to have object which will be actually able to place those buildings. So let's create another script. But before we do that, let's have a look at the input action asset. Over here I have 3 actions which will be relevant for us today. And basically the first one is the perform action, which is of type button, and it is bound to the left mouse button. Then cancel action, which is nothing more than another button type action, which is bound this time to the right mouse button. And then I have also the mouse position action, which is of type value, and the important thing is its control type is vector2. That basically allows us to get the mouse position on the screen in convenient vector2 as we know it from the old input system. Then its binding is of course the mouse position. Just be careful because there are some other options and the mouse position is exactly what you need. Then my input actions generate C# class, which is in the game input namespace. This is very important. Be careful to do not use the input namespace. I always use the game input instead, because you will have some issues. There is already existing input namespace, and you will run into some conflicts, and it's completely unnecessary to add this type of complexity. So it is doable, but it won't be easy to work with. Then in my scripts, I have, of course, the auto-generated class, which very importantly is marked as partial. And this is something that is done automatically by the generator. Basically, if a class is marked as a partial, it means we can create another class with exactly the same name. So over here I have my file input actions.ext, because of course you cannot have 2 the same files in one folder. So I'm keeping them in one folder, so they have to have different name. And then you see I have them in exactly the same namespace. So this one is in game input namespace. And of course the auto-generated one is also in the game input namespace. Now what I can do here, I can create another class with the word partial. And basically whatever I add here is treated as original input actions class. So over here I create this static field of type input actions, which allows me to store their specific instance of input actions. And whenever somebody tries to get the instance using the property built on top of that field, what I do, I check if the instance already exists or not. And if it doesn't exist, I create new input actions and then straight away enable the input. Then I simply return the instance. So of course, the second time, third time, fifth time, whenever somebody tries to get it, they will get exactly the same instance. And I find it perfect for a single player game. I don't have to worry about anything. I have it easily accessible. I don't have to think about smart ways of passing around one instance of input actions, and it is really convenient. I am sure there are better ways of doing that, but to be fair, I really didn't find much of downsides, and it is pretty convenient to work with. If you have better alternative, please let me know. I'm really happy to learn about it. Now on top of those input actions, let's create a class which will allow us to conveniently access the mouse data. So inside the game input folder, I create another script. I call it mouse user. I move the script to the right namespace. And first inside of it, I create a field of type input actions to store the input actions that it will be based on or will be using. So now I will need two methods, on enable and on disable. On enable, I want to assign the input actions. So that will be pretty easy because we have our input actions.instance. And then I will want to subscribe here to several events. There is a little bit of data that we will be using or we will be needing, and those will include. So first we'll need a property for the mouse position. So that will be vector2 mouse position. Private set. Then another one for the mouse position, but already converted to the world coordinates. And we can actually do it on flight. So what we can do, we can create the auto-calculated property mouse in world position. And whenever somebody tries to get it, then we simply do camera main screen to world point and then provide the mouse position. Awesome. Then it would be good to have information about the pressed buttons, right? So for that, let's create two private fields and the same one for the right mouse button. Awesome. And we'll create a method on top of them. But to make it a little bit more usable, let's first create a small enum. So public enum mouse button, and over here, let's just give it two values, left and right. And now let's create a public method is mouse button down or pressed, just to keep the naming consistent. And as a parameter, we'll take the mouse button enum, and if the value provided is left, we'll be returning the is left mouse button pressed, and otherwise we'll return the right one. And we of course need to return that value. But now we need to populate those informations, right? So for that, we'll need several methods. First one, on mouse position performed, because that's how my action is called. Callback context, and whenever the mouse position is changed, I simply want to assign to the mouse position the new position. So read value vector2. Perfect. Now I need to subscribe to a specific event. So input actions, game, mouse position, performed, boom, done. And also, of course, on disable, I want to unsubscribe. Then I need another one for the left and right buttons. So on perform action performed, callback context, is left mouse button pressed, I will simply set it to true. Then when the action is cancelled, that means the button was released, I turn it to false. Then I will need two very similar methods. So on cancel action performed, and of course on cancel action cancelled. And over here we want information about the right mouse button. Now we need to subscribe to all the events. So input actions, game, perform action, performed, on perform action performed, then of course cancelled. Of course I misspelled cancelled. And now of course we need exactly the same thing for the other button. So for cancel action, oh, of course, wrong methods. And of course, later on, I need to unsubscribe. That will do it. So now let's create finally the class responsible for placing buildings. So I'm going back to Unity and creating inside the building system folder new script. I call it building placer. And of course, let's move it to the namespace. And now let's remove those. First, of course, we'll need a property for the building we want to place. So field, serialized field, and now public buildable item, let's call it active buildable, public get and private set. Awesome. Then, of course, we want to build within only certain range from the character. So let's create a field for that. For the distance, of course. Private float max building distance. Let's default it to something like maybe 3. Then let's create another field, this time to store the reference to the construction layer. Awesome. And of course, another one for the script we just created. Okay, let's create the update method. And inside of it, let's check the distance between player and the mouse position. So let's create for that another method, is mouse within buildable range. And now we simply return vector-free distance between the mouse word position and our own position. And of course, we compare it to the maximum building distance. So the distance has to be smaller or equal. Awesome. So if the condition is not met, let's simply return. Now, if the left mouse button is pressed and we have a buildable, so our active buildable is not null and our construction layer is not null, then let's build the item on the construction layer. So build the mouse user mouse inward position, and the second parameter will be the active buildable. Let's go back to Unity and let's place our script on the little elf. So our building placer, the mouse user, let's fill the references, so we have that. Active buildable, let's for now just select the only buildable we have, so the stone path. We need to also assign the construction layer script to our tilemap, so script, building system, construction layer. Now we can fill that reference to on the building placer, and that should be it. Okay, so we can build the tiles. Awesome. But now we'll see that we have a problem with sorting. So at certain point, you see exactly in the middle of the tile map, the character gets behind it. So let's fix that. There are a few settings we have to adjust for that. The first one is on our URP renderer. So I have it in my URP folder. If you create URP project using the Unity Hub, you will have it too. So it's over here, and basically the first important setting for us is the transparency sort mode. We have to make sure it is set to custom access. I think by default it is set to Z be 1 and the Y being 1. We have to make sure that the Y is set to 1. Basically what it means, this setting controls in what order the objects are sorted on the screen. So basically the default, if I remember correctly, uses the setting from the camera. And camera can be perspective or orthographic. So basically this one is the one used for 3D usually, and this one is using for 2D and isometric. So basically we are not interested in any of the predefined settings. So because if we select those ones, you see the setting below is disabled. So we select the custom access. And what Y1 means, it means that basically sort those items over here depending on their Y position. So that's over here, that's the first thing. Then we have to go to our construction layer, so our tilemap. On the tilemap we have a mode setting. We have to change it from chunk to individual. What this means is basically that each tile that is drawn will be rendered as an individual body rather than a one common thing. This means that each one will be sorted separately rather than the whole tilemap as one. So this is pretty important. Then whenever you have sprites, right, so the good thing is you can select all the sprites together, and you see they have the sprite sort point setting. We have to change them to pivot. So basically this setting is on the sprite renderers. By default it's center, we have to change it to pivot. But that's not all. So for the tiles to be sorted correctly, we have to edit the sprite, like sprite file. So I'm clicking on the file that contains all the sprites that I will be using, and I press the sprite editor. And over here I'm going to select this particular tile and move its pivot point to top. So I'm not sure you see it, but the blue circle moved to the very top of the sprite. Basically the sorting will be around the pivot point. So for example, looking at this particular sprite, the collider will be there, not allowing me to go inside or behind it, so I won't be bothering by that. But if you would like, for example, the collider to be only at the very bottom, you could move the pivot point over here, and then this would be the sorting point. So this is what would be compared against the pivot point position of the character. Okay, once I change the pivot point, I click apply and close it. This is kind of a little bit problematic, because what will happen now, if we look at our tile map and open the palette, you see our sprite or our tile is basically offset half. So when we paint with it, you see they are offset, so this is not the best thing, but the fix is pretty easy. So we select the tile we want. So first you have to make sure you have this tool selected. So select an area of the grid, and then you press edit. We click over here, and over here we have some settings. One of them is being offset. So you see if we change the offset in Y, it is being adjusted. So half is exactly what I'm interested in. I exit the edit mode. If I select this tile and start painting with it, you see everything is correctly displayed. So I'm going to clear all of those. But the problem is this setting, unfortunately, is set only for the tiles placed using the tile palette. So this works fine, but if we now start the game and paint the tiles ourselves, we see that they are offset. So this is a little bit problematic. But there is a easy fix, but we have to do it in code. I'm going to open my building item, and I'm going to add extra field, or maybe property. It will be of type vector3, and it will be called the tile offset. Awesome. Now when I open my scriptable, my stone path, I can set the offset in y-axis to be equal to half. But now we have to use this information while placing our tile. So let's go to our construction layer class. Over here we have the method that sets the tile. Unfortunately, there is no easy method to set this offset, so we have to do a little bit of hacking around. Instead of using this method, we can use another method which has exactly the same name, but requires us to provide different pieces of information. The first one being the tile change data. So let's create that. So basically this is the information for a tile map about how to place a specific tile on the screen or on the grid. So we can do that. And you see the constructor has 4 parameters. So let's fill them up. The first one will be the coordinates. This is pretty easy. Then the tile, we have access to that, it's also pretty easy. Then the color, we want the color to stay white, nothing crazy there. Now, matrix 4x4, and this is where it gets a little bit crazy. I don't really understand the math behind it, but we can simply use the clean matrix and then translate it by a certain vector. So what we can do is, you see, matrix itself has this beautiful method translate, which requires us to provide a vector free. And now we have that vector free. It's called tile offset. So beautiful, we have that. So we can use that instead. Now, there is another parameter which we have to provide, and that is basically a flag which dictates if special flags on the tile should be respected as they were set on the tile base or not. Of course, we don't want to ignore them. We want them to be respected because for some reason somebody set those flags, right? So let's say false, and this should do it. And now we have some tiles which were placed before, and when we try to place ours, they will be placed correctly. And the sorting is also as expected. Awesome. Okay, let's start working on a preview. For that, we'll have to know if a certain place on the grid is empty. And not only in the sense of the tile map, so it's not as simple as just checking if this particular grid cell is empty. We'll also have to have information if we don't have there any game object, because our buildables very soon will not only be tiles, but also regular game objects. So let's first handle that. So first, in our building system, let's create another folder. Let's call it models. Let's move the buildable item there. So let's open it. Let's move it to the new namespace. Awesome. And now let's create another script over here, which we'll call just buildable. Okay, so this one will be just a regular class. So we remove the mono behavior, we move it to the right namespace, and remove the unnecessary methods. So we need to create several serialized properties, but first we need to mark the class as serializable. Basically what it does, it makes the class available in the inspector. So if you would have somewhere a field of type buildable, but it wouldn't be serializable, you will not see that particular field in the inspector, because obviously Unity won't be able to serialize it. So this literally means, okay, you can serialize it. Now let's create those properties. So first one will be for the parent tilemap. So because obviously we need to know on which tilemap we place the buildable. So field, serialize field, public tilemap, parent tilemap. And this of course requires us to import the missing reference, which is the Unity engine tilemaps. And now get private set. Awesome. So then we need another one for the buildable item, right? So public buildable item, and let's call it buildable type. So this will basically determine of which type of which buildable item this particular buildable is. So get private set. Then, as we said before, we'll sometimes want to create a game object. So let's create a property for that too. Game object, and let's call it just game object maybe. Get private set, awesome. And then the last one will be for the coordinates. So serialized field, public vector free int, and now coordinates. Get private set. Now let's create a constructor that will allow us to provide all of those information. So public buildable, and now it will always have to have the buildable item. Then it will always have to have the coordinates and the parent tilemap. But the game object will not be always there. So for that, let's do that, and let's default it to null. Awesome. And now just let's store the information. Awesome. Or maybe let's rename this one to game object. Awesome. We'll be extending that in a moment, but now let's go back to our construction layer. Over here, let's create a private dictionary that will have keys of type vector free int, so the positions on the grid, and then as the value buildable. So it will basically store which buildable is where on the grid. Let's call it buildables, and let's initialize it. Now let's import the missing reference. That will be the system collections generic. When we build a building, let's create a buildable instance, new buildable, and let's provide all the informations we have. So we know the type, we know the coordinates, the tilemap as well, and the game object. At this moment we don't do anything about it because we don't yet really do anything with it. So let's leave it like that, and then at the very end we can add this buildable to the buildables. So add those coordinates, we want to add our buildable. Awesome. So we have that, and now we have to create a method that will allow us to check if the space is empty. So for that, let's create public bool is empty. And for now it will simply require just one parameter, vector free world coordinates. And what we'll do, we'll literally convert those ones into the grid coordinates, and then we return if the buildables contains key or not. So basically, if it contains the key, that means the cell is not empty. If it doesn't contain, it means we have nothing there, so the cell is empty. It's time to create our preview layer. So back to Unity, and inside the building system, I'm going to create new script and call it preview layer. I open the script, make it extend the tilemap layer, move it to the right namespace, and remove the methods. So because we will be previewing not only the tile things, but also regular game objects, it will be better to have a preview based on the sprite renderer rather than display it somewhere on the tilemap itself. So for that, let's create a serialized field, private sprite renderer, preview renderer. Awesome. Okay, and now we need two methods. So first one will be public void show preview. And of course, we want to know which buildable item we want to preview. And then, of course, we want to know at what world coordinates. So world coordinates. And then we want to know if this is valid or not. So we can change the color of the preview. So that's this one. And then, of course, we will want to have another one, public void clear preview. Awesome. So first of all, of course, we need to convert the coordinates. And that is the reason we are using the tilemap layer instead of the regular just mono behavior, because this way we can have access to the underlying tilemap. So we don't have to do all the work. Once again, world to cell, world coordinates. Awesome, we have that. Now we want to enable the preview. So we want to make it visible. Now we need to set the preview position, sprite, and color. So preview renderer, transform position. Then we need to do something a little bit crazy. So we take tilemap and convert the cell to world position. Over here we provided vector free. Here we converted to the vector free int, so to the grid coordinates, and then we converted back to the world coordinates. So let me tell you why we do that. So first we have world coordinates. Let's say something like 7 and 23 f, and for clarity just let's keep it x and y. So 12.5 f. So those are floating point numbers. Then we convert them into the vector free int. So those become, for example, 3 and 6, for example. And the reason is those numbers will not be just the integer part of those floating point numbers. That's because our tilemap may have a different position. The tilemap may have a different cell size and different origin and many other different things. The important thing is to remember that those ones that are in coordinates will be integers, and they can, but they don't have to be exactly the same as the integer part of those floating numbers. But then when we convert it back into world position, this is not simply going back to those values. This is always the origin or the pivot point of the cell size. So for example, this one converted to the world position won't be anymore 724, but will be, for example, just 7. And this one, 12.5, will be now 12. So this gives us a position of the left bottom corner of the tile. So in our case, to have a central position, we have to simply add half of the tile size, so cell size. And then of course we have to divide it by 2 because we want just half of that. So this will basically show the get us the middle of that particular tile position in a world. So that's done. Then of course, when we preview something, we want to have the right sprite, right? So we don't have that information currently, so we have to adjust our buildable item to give us this information too. So let's create another serialized property, public sprite, and now preview sprite get private set. Awesome. So we have that. And now we can simply do item preview sprite. And for the color, we can simply check if the parameter is valid, is true. If it is, we just put here new color 0, 1, 0. That's a pure green, so like lime color. And then point half alpha, so it will be half transparent. If it's not valid, then we want new color 1, 0, 0, which is red, and then 0.5 to have it again semi-transparent. We'll be adding to that in a second a little bit more. And now if we want to clear the preview, we simply disable the renderer. So this is as simple as that. Now we have to use it somewhere, right? So first, to do not forget, let's add the sprite, the preview sprite, to our stone path. So for that, I can simply select the sprite I'm having for that. Then let's go back to the script. And over here, let's go to the building placer. Okay, so here we will need also the reference to our preview layer. So let's add it just under the construction layer. Serialness field, private, preview layer, preview layer. Awesome. So we have that. And now, of course, if our mouse is not within the range, right? So we have to just change that. We first clear the preview and then return. Now let's add also another condition. So if it is not within the range or our active buildable is not selected, so it's null, because sometimes we may, for example, when we have inventory system or something like that, we may hold just now not a buildable item, right? So if the active buildable is null, then we also clear the preview and then we return. Otherwise, we want to show the preview. For that, preview layer, show preview, and we have to provide it some information. So first, our active buildable, of course. Then we want to provide the mouse position. So for that, we can use this beautiful field, or rather property, and then we need to give it information if this position is valid or not. So for that, we can simply check if our construction layer is empty at that particular position. So we can just once again provide that. As we know, this position is calculated on flight, so this would require the camera to recalculate it every single time when we call it. So instead of that, we can also make a variable for that. So mouse position, and do that, and now simply use this instead. Over here, and over here. So now, when we go back to our Unity scene, we can, on our construction layer, put also the preview layer script. We are not placing anything on the grid, right? We're just using the grid to get the right position of the item. So let's grab that. In the building system, we have the preview layer. So I'm drag and dropping it over here. And also I need to have the preview renderer. So for that, let's create another empty object under our grid. Let's call it preview. And let's add to it the sprite renderer. So we have that. We can disable the sprite renderer by default. And simply on the construction layer, we just fill this reference. Now on our elf, we also have the reference for the preview layer, which we have to fill. And we have it almost done. So if I test it now, we see we have the preview. But when we place the building, there are two problems. First one, you see the preview is not in the right position. It is offset by half. This is one thing we have to fix. And then also you see when I hold the left mouse button, I'm getting massive amount of errors. So those are very easy things to fix. And the first issue is that in show preview, we position the item at the center of the tile, but we don't take into consideration the offset that we set on the item. So let's add that too. So plus item tile offset. Let's just organize it a little bit. Awesome. That will fix the first problem. And then the second one is actually in the building placer. So now when we try to build something, we should also check if this position is available. So construction layer is empty, and now just the mouse position. And we should have both of the issues fixed. And now, amazing. So we see that the preview is in the right position, we see the color changing as expected, and also we see no errors over there. Also, we have one more problem, which is basically when we place something within a game, it works great. So we cannot place it again, and the preview works as expected. However, if the item was placed before the game started, we do still have a problem. So let's fix that too. For that, the fix is also pretty easy. So in our isEmpty, we also have to check if the tilemap get tile at given position, so chords equals to null. So now this checks for both things. First, if the buildables do not have that position registered or anything in that position registered, and then if the position on the tilemap is free to be occupied. And beautiful, we see that we cannot do anything. This position is also marked as incorrect. So now we also see the important thing that we see preview only within a range, and we cannot build outside the range. So everything works as we would like it to. Boom, beautiful. Now let's add fence, another buildable item type. For that, I'm going to my scriptables folder, buildable items, and creating new buildable item. I call it wooden fence. I give it name, wooden fence. I don't have yet tile for that. I will want no offset, and for the previous sprite I just want empty or like just a single wooden board with a nail in it. So that. Now let's create the underlying tile. Or maybe before that, let's make sure that our collisions are set up correctly. So first thing is on my construction layer, I have to add the Tilemap collider 2D. So as we see, this just adds colliders to every single tile that's there. Now I'm going to add the composite collider 2D. So this is going to simplify the collider. First, we have to make sure that the used by composite is checked. So that's this. And suddenly we see that those were simplified a little bit. They have a little bit of space around them, so they don't connect together. But if the tile would be occupying the whole space, basically they would be nicely connected into one tile, or rather one collider. So we have that. Now we have to also add collider to my little elf. So for that, let's use, for example, capsule collider 2D, of course. Let's make it horizontal, a little bit smaller in Y, actually very small in Y. So maybe something like that. Let's move it a little bit up and then make it wider. Something like that will do. Now I have to make sure that in my constraints on the rigid body I have frozen the rotation, because otherwise on collision my character would start rotating weirdly. Would be also good to have some physics materials, so the character doesn't slow down or behave strangely when it collides with the items. Physics materials. And I'm just going to create new one by going to the 2D, physics material 2D, and call it smooth. I'm going to change the friction to 0 and then apply it to first the construction layer and then also to my little elf. Oh, and of course, we have to remember that on construction layer, when we added the, I believe, composite, the rigid body has been added automatically. So what we have to do is to change the body type to static. Otherwise, basically, the rigid body would make the tilemap to move. Now let's test it, and we see we cannot walk through the path, and this is not really what we want, because our character should be able to walk on it. And again, there is very easy fix for that. So on the tile, we have some settings: tilemap, buildables, and stone path. Over here we have this collider type setting. Grid will make it basically occupy the whole space. Sprite, of course, will make the collider to be adjusted to the sprite size or sprite shape, and then none, which means there will be no collider whatsoever, and this is what we actually want for our pavement. So let's try it, and all works great. If we place new ones, this is also working as expected. So now let's create new tile. For that, let's in the buildables folder, and over here, let's create a rule tile. So we go to the tiles and then rule tile. Let's call it fence. And the rule tiles are basically special type of tile that allows you to set certain type of rules that changes the sprite depending on the placement of that tile. So for example, if we have fence, of course we want to have different directions, right? Depending if we have tile also on the left or not, then we want of course to make it connected, and so on, so on. You will see what I mean in a second. Over here, I'm going to keep the default collider as a sprite, because for this one I really don't want the character to go behind the fence. And now I have here the tiling rules. So for the first one, let's just select the empty one. And now I need to indicate when this particular sprite should be used. So in my case, because there is no connections on any side, I want it to be free on all directions. So over here I have to put X's. So basically when there is X, it means it's hard edge. There is no another tile of the same type next to it. If I put there the arrow, it means there's continuation of this type of tile. So let's do that. Now let's add it to our tile map. So I open the palette, I drag and drop it over here, and I will draw some shape just so we easily see what is happening and how the rules affect what we do. So now let's use this one, and let's draw maybe something like, maybe let's replace those ones. We see nothing happening. This may be strange, but that's because we don't have a default rule. So right, if I place over here a tile and there is no tile around it, you see, as expected, if there is no tile around it, then this sprite is used. But we don't have rules for the rest. So now let's add another one. So let's do this one. For this one, we have continuation to the bottom and to the right. So let's change that and that. And we suddenly see this one appeared. Duplicate this one. Let's use the middle one. And we have continuation also on this side. We add next one, and it will be this one. So this have to be empty on this side and have continuation on those two. Next one will be this one, hard edge over here, and continuations over here. And it looks like I have all the rules in place. So let's test it out now, drawing some more complicated things. So over here, works as expected, this as well, and this too. Awesome. So now we can use the power of that to create our building. So we don't have to really write any code to have that working. So we literally can use this tile as our scriptable buildable item. So I go to the wooden fence, as the tile, select my fence. Actually, let's make there an icon, because I don't like it not having an icon. So default sprite, let's just make it let's make it that, or maybe let's go a little bit fancy and just put it this way. So now we actually have everything, because we don't want the offset to be there, because our pivot point for those ones is in the middle. So everything is set up. And now if we, on our little elf, on the building placer, change the stone path to the wooden fence, and now my character can build the fences as well. And we see the collisions work as expected, so my character cannot go behind it and through it or anything like that. Awesome. I'm not sure you noticed, but our preview is visible when the tile is not built, but once we build it, the preview is going behind it. So let's quickly fix that. On our preview, on the sprite renderer, I'm going to change the third layer to be on the foreground. If you don't have this layer, it's as easy as going to add sorting layers and just clicking the plus icon and adding your ones. So I have that, and this actually should be enough, because the construction layer, I guess, is on the default one. Correct. So this one should fix the issue. Awesome. Looks great. Let's now add the ability to change the buildable item. So I'm going to the building system folder, and I create new script and call it building selector. I'm going to add it to my little elf and open it. Move it to the right namespace and remove the methods. First, of course, it has to have the list of available buildables. So private list buildable item, and let's call it buildables. Let's just import the missing reference, and then we'll be setting the property on our building placer, the active buildable. So let's create a field to store the reference to the building placer. Private building placer, and let's call it building placer. Nothing crazy here. And of course we want to know which is the current active buildable. So active buildable index. And now in my input actions, I have some keys set up. So I have Q and E set up. So let's use E as going to the next item. So we'll, for simplicity, just go one direction. So private void on enable, and over here I can subscribe to the event. So input actions, that's the class I created, instance, and then game map, then the next item action, and when it is performed, I want to do something on next item performed. We don't have that, so let's generate that method. Let's change the name of the parameter to the ctx, and now let's call the next item method, which we also have to create. So private void next item, and this will be as simple as changing first the buildable index. So for that, we first increase the value by 1, and then make a modulo buildables count. So the idea behind it is, let's say our count is equal to 5, and let's say our index is at this point 1. So if we add 1 to it, we'll be having 2. And then if we take modulo from 2, the result will be 2. If we do modulo from 2, that will give us 2. Because basically how modulo works, it gives us the rest after division. So 2 divided by 5. If we look at the integer part, that's 0, right? And then the rest is 2, because basically 5 times 0 equals 0, and 2 minus 0 is 2. So the same way, if we now change from 2 to 3, so that's plus 1, modulo 5 then the result is 3. Exactly the same reason, because 3 divided by 5 equals 0, and then 0 times 5 is 0, and 3 minus 0 is 3. But then when we change from the last valid index, so if we change from 4 to 5, and we make modulo 5, the result will be 0, because if we divide 5 by 5, that will be 1, and 1 times 5 is 5. So now 5 minus 5 equals 0. So we literally just looped to the beginning, and this will be going the same way over and over. So we have the active index, but now we have to somehow set the actual buildable on the building placer, and it turns out that we don't have yet a method for that. So let's go to the building placer and let's add the simple method. So make it public void set active buildable, and of course we want here buildable item, and let's just assign it to active buildable. So that building selector set active buildable, and now it's as easy as selecting from buildables the item under this new active buildable index. So we have that, and I think this is actually all we need to have that working. So let's go back to Unity. I click on my little elf, and now we have this script over here. So we at this point have only 2 buildables, so let's increase the size of the list. And now as a first one, let's select the stone path, and as the second one, let's select the wooden fence. And then our building placer is just a building placer script from the same object. And then on our building placer, let's just set the active buildable to none. So now when we start, we should have no errors, but we shouldn't be able to place anything. Now I'm pressing E, and we see that I'm starting, I can build the fence. Now let's change to the other object. I pressed E again, and you see I can place the pavement. So over here, and we have it. So I press E once again, and I'm back to the wooden fence. Awesome. Okay, now on top of our building selector, let's create simple UI. So I'm going to add the UI image. It will be really extremely simple UI. And let's call it active buildable. Let's just zoom out to see the whole canvas. And let's change some settings. So first I'm going to change the UI scale mode to scale with screen size. And then I think we can leave all the settings as they are. We can focus on our active buildable, and then let's change its anchor point while holding Shift and Alt, so we also change the pivot and the position. So I'm going to put it in the top corner. Then I'm going to change its size to something like maybe 75. I actually think this is still quite big, so let's put 50-50. And then I'm going to move it a little bit from the edge. That will do it. Let me just check it in game. Yeah, looks all right. And what we need to do now, we need to write a script. So in our building system folder, I create another one called UI. And inside of that folder, I create a script and call it UI active item indicator. Awesome. I open the script, put it in the right namespace, and remove the unnecessary methods. So we'll need a way of communicating between this component and our building placer. So inside of our building placer, let's add an event. So public event action, and let's call it on active buildable changed. And if in case you are not aware what action is a type of event that doesn't return anything. And now there are many kind of different types of action with many, allowing you to provide different types of different generic types. And basically that means that if you, for example, provide an int now, that means when you invoke, you will be passing an integer as the information about what happened. But in this case, we don't need any type of information because our UI component will have access to buildable item through the building placer. And so that will be enough. Of course, we need to invoke it when the active buildable actually changes. So let's scroll to the very bottom, and over here in the set active buildable, let's paste it, add the question mark because we may have nobody subscribed to that event, and then simply invoke. Great. Now we can go back to our UI active item indicator. So over here, as we said, we need reference to our building placer. So private building placer, building placer. And then we need another field, this time for the image that is attached to that UI object. So private image. And now important thing is that we import the right image. For some reason, oh yes, it's over here. So we have to make sure that we use the image from the Unity engine.ui namespace. And there are a few others and they will not work correctly. So we have to have this. Just let's import it. Awesome. And then let's call it icon. Now inside of our awake method, let's just store in the icon the image component. Awesome. Now we'll need a method that will allow us to actually change the sprite on the image to the one that we want to show on our UI. But currently we don't have anything like that on our buildable item. So let's add it. We have the previous sprite, but sometimes we'll want to have different sprite in game and different one on the UI. So let's add property for that. Field, serialize field, and now public sprite UI icon, get private set. Awesome. Let's go back to the UI active item indicator and let's create a method that will change the sprite. So private void, and let's call it on active buildable changed. Awesome. It doesn't require any parameter as we said, because as a type of the event we use action. And now we can simply change the icon sprite to the building placer, active buildable, and UI icon. May happen that the building placer doesn't have any active buildable. So for that we need to just make sure that we handle that. So if our building placer active buildable is not null, then we want to do the action below. Awesome. And we also want to make sure that the icon is visible. So we want to make sure that it is enabled, because when there is no active buildable, we can simply disable the whole icon and nothing will be visible. This will be pretty easy and pretty nice actually. So in our awake method, we now have to subscribe to the event on the building placer. So building placer active buildable. I see I named the event on active buildable changed. It's incorrect name because the event itself shouldn't contain the on part. So let's go back to the building placer and just let's adjust that. So over here and then in the method over here. Awesome. And now this will do it. And now we just add our method. And now on the start, let's also call our method. So on active buildable changed. This will ensure that we have the right sprite when the game starts. To our active buildable UI element, we have to add the script. Now it has the reference to the building placer, which is on the little elf, so let's drag and drop it. Done. Now we also need to set the UI icons on the scriptables. So let's go here for stone path. Let's just use the regular building tile, And then for wooden fence, I do actually have dedicated icon. Great. So let's save the scene and let's test it. And as we see, we start without icon because there is no active buildable. Then I'm pressing E and suddenly you see the preview appeared and the icon over there too. So everything works as expected. Now let's change it to the stone path and everything works as well. So let's now once again change to the fence and everything works. Awesome. Let's now create the third buildable item, but this one will be slightly different because it won't have any tile, but instead it will have a game object. So I'm creating new buildable and I will call it mannequin. I'm entering its name. Then, as we said, there will be no tile, it will have no offset. For the preview, I will set the actual mannequin sprite, and then the UI icon will be this little icon I prepared. Now let's quickly create the underlying game object. So I'm creating empty game object. Let's call it a mannequin. And let's drag and drop the sprite under it. Let's just fix the typo over here and over here too. And maybe actually let's keep it as sprite. So this way the structure is a little bit clearer. We know what is what. And now let's ensure that the position of the sprite is the correct one. So here we need to reset the transform. Beautiful. And now let's place this mannequin in the prefab folder. Done. So now I can safely remove it from the scene. And on my scriptable, I will have to add the property for a game object. So let's go to buildable item and let's create new property. Field, serialize field, public, game object, and let's call it game object. Get private set. Awesome. Let's just add a little bit of enters here. Yes, much better. Okay. Now back to Unity, and over here I can select the game object. So I can select one of those three and I want my mannequin object. Awesome. Now inside of our construction layer, in our build method, let's start by creating a variable for the game object. Let's call it item object. Now we checked over here if we have the tile, and if we do, we create the tile. After that, let's check if we have the game object. So if we have game object, then let's take the item object variable and assign to it instantiate item game object. And now, because it is a game object, not a tile, we need to provide some extra information. So the first one will be the position. So we want to convert the tilemap coordinates toward position. So cell to world, we provide the coordinates. Now we want to add to that half of the cell size. And now at the end, of course, once again, we want to add the offset. So item tile offset. Awesome. And then we also need to provide the rotation, which will be simply quaternion identity. Now we can actually use this object and pass it to our buildable. So over here we don't use the buildable. The first place where we use it is over here. So let's move this variable over here and then let's grab the item object. And if you remember, our buildable has the optional parameter in the constructor, and let's make a use of that. So back to the construction layer, and as a last parameter, let's pass that. And of course, now we get a complaint that the item may not be initialized before accessing. So we have to make sure that we initialize it as null. And the issue is gone. The good thing about it is that when we place the object into the buildable, even if there is no tile, right, we add that buildable then to our buildables. That means this coordinate where we put this object will also be occupied, so we won't be able to place there any other tile. Let's just test that. So on our little elf, on our building selector, we can add new buildable. So let's put it over here and let's have a look how it works. So fence working as expected, and you see we are able to place the mannequins as well. Of course, the mannequin for now doesn't have any collider, so this is a little bit problematic. And I also see that we are sorting based on the center of the sprite rather than its pivot point. So let's adjust that. Let's open our prefab, so double click on the prefab, sprite, and the sprite sort point will be the pivot. This automatically was changed for us, and let's test it once again. So fence, and now mannequin. Great, this is exactly what we wanted. Now if you see, we cannot place the item on the fence, and the same way we cannot place anything where the mannequin is standing. Whee! Awesome. Okay, so now let's handle destroying the buildings. For that, let's go to one of our scripts and let's start with the buildable model. So over here, this is an item representing our buildable in the world. And it has all the things that are necessary to actually clean up after it or destroy it. So let's create a public void destroy method, which will check if the game object is not known. And if it is not, we'll simply destroy that object. Because this class is not mono behavior, you see over here, we cannot just simply do destroy. There's no method like that. Now it shows because it kind of detects this method over here, but we cannot use the regular destroy method, but we can use it if we use it through the object dot destroy. Awesome. And now we can just pass the game object. Awesome. So that's handled. And now we have to clean the parent tilemap. For that, we can simply set the tilemap at given coordinates to null. This way, we'll basically just clear any tile that's at that position. And now let's use it in our construction layer. So our construction layer has already build method, so now should have also the destroy method, where we just simply pass the word coordinates and everything is handled for us. So let's do that. So public void destroy. We of course accept web vector free coordinates, so word coordinates. And now, of course, first thing we do, we convert it to the cell position. So that's done. Now we have to check if there is anything under those coordinates in our buildables. So buildables contains key chords. And if it doesn't contain that key, so that means there's nothing built under that position. So on that position, we can simply return. But otherwise, so if there is something, let's just grab this buildable. Awesome. And now let's remove it from the buildables. So we can do that using the remove method with the key. So that's the key. And now let's also call the destroy method on our buildable. I know we could simply just do that and then .destroy, but there is some extra stuff which we'll be doing in a moment. But for now, this should be all. Okay, so now let's use it in our building placer where we actually handle the user clicks. Okay, so first let's separate those two conditions. So if we are not in range, we'll want to clear the preview. Over here, this will be already done, and of course we need to remove that too. And now, if our right mouse button is pressed, just before we do that, let's do a little bit of cleanup. We don't need to check if the active buildable is not null, because we check it here. So let's remove this check, it's unnecessary. Then the construction layer will be needed for all of those, because if it's null, we cannot check if the construction layer is empty. So let's extract that and let's move it somewhere up. So we can do that over here. So if the construction is null, then we return. And then we have some other ifs which are just for one condition. So let's move those ones too. It will make the code a little bit shorter. So this one as well. And it looks much better now. So over here, if we have the right mouse button pressed, what we want to do, we want simply to call on the construction layer the destroy method at the mouse position. So we can move that up over here, and then let's use it here. Maybe enter over here, and let's remove empty space here. And this will do it. So basically what we changed, we cleaned up a little bit of the conditions, and we also added this part, which basically checks if the right mouse button is pressed, and then if so, we grab the mouse position and try to destroy what is under that position on the construction layer. So over here we have a small error. Those shouldn't be separated. So basically, if we are not in range, or if the construction layer is null, we should clear the preview and then also return. Let's test it. So this, and this. And now I'm pressing right mouse button and I'm clearing the positions. Everything works. So we see that the spaces straight where I are unoccupied because we can place new items. Awesome. Okay, now we do something a little bit crazy. So let's start by adding another layer under our grid. So grid to the object tilemap rectangular, and let's call it collision layer. Basically, what we'll do, to present it, let me just add to the tile palette a simple rect sprite. So if you don't have it, you can just click right mouse button, create 2D sprites and square. So I'm going just to drag and drop it over here. I'm going to save it on the tile map. It is on the buildables tile palette. So let's call it collision or collision rect. Awesome. And basically what we'll do now, when we place an item on a map, for example, imagine it is building and it is much larger than this simple mannequin. We'll be able to mark on the collision layer where what should be its collision zone. So basically how many tiles it should occupy, both on the construction layer but also on a special collision layer. So now you will be able to, for example, place a tree that will be this big, right? But you want its collisions to be equal to those for tiles. So this is what we will implement now. Okay, so first let's clean this up. Okay, for that, let's first go to our buildable items. So models, buildable item, and let's add another property. Field, serialize field, and now public RectInt, and now collision space get private set. Basically what a RectInt is, it's a structure that stores some information about simply rect. So basically you see on the screen that it has the x, y, width and height, and then it does some extra calculations based on that. So this is pretty convenient. And I think that it would be actually good to have another one, property, which would be called, would be of type Boolean and would be called use custom collision space. because sometimes we may not want to use it or want to be able to quickly disable, but still store the information there. Plus, because this is structure, the default value is not null, but something that the structure defaults to. In this case, it would be just a new RectInt, so something like that. So let's remove that. But now, first thing we have to do, we'll need some extension methods, which will help us to work with the rect in a little bit more convenient way. Because what we'll have to do pretty often is we'll have to, when we have the collision layer, basically what will happen, we'll have to, for example, if we have those 6, let's say we want those 6 cells to be occupied, we'll have to iterate through all of them. So this is pretty tedious and we'll have to do it, I think, at least 3-4 times. So let's just help us a little bit and create some helper methods for that. So in our scripts folder, I'm going to create another one and call it extensions. And inside of that folder, I'm going to create a class which will be called RectInt extensions. If you are not aware what extension methods are, basically sometimes you have a type that, like this time, we have RectInt, which doesn't belong to you. So this is part of the Unity engine namespace, and there is no easy way to add extra methods to it, right? Sometimes we want to be able to do something. So for example, we have a rect and we would like to have a remove method on it or something like that, and it doesn't exist. So extension methods are basically a way of adding those extra methods to instances of a specific class. There are several requirements though. So first of all, the class that defines those extension methods has to be static. So that's over here. And now when you create the extension method, it has to be static. And then our one will be called iterate, because we'll be iterating through the whole rect positions. And now this will be a little bit strange, but we have to use this keyword followed by RectInt. So this, and then the type that we extend, we give it any name like we would to any parameter. Now I need to import the reference. As I said, it lives in the Unity engine namespace. Then we provide the rest of the parameters, which will be just regular parameters to the method. So in our case, we'll want to start the iteration at certain cell, right? So we want to provide the coordinates. So maybe let's stop here for a moment. We'll have to add another parameter in a moment, but for now, let's just create the iteration part. So in order to iterate through all the position, we want to start, for example, with x, and we want to start at the rect x, which is like x of the origin of the rect or position of the rect. And then if x is smaller than rect max, so this is basically the last x that's part of this rect, then we simply want to increase it. Then we want to do the same thing for y. So var y, let's start with the minimal y. Then when it is smaller than the maximum y that's part of this rect, then we want to increase it. Now we have to do something, right? And this is where it gets crazy, because we don't have any method that we want to call, right? And we want this method to be pretty generic in the sense that we want to be able to provide a method and just execute it. Let's create this method definition. In the sense, there is something called delegate. And delegate, it is just a regular type that stores the method, right? So we can literally, like we pass here some information, pass a method, which then will be able to execute. But first we have to create a type for it, which is called delegate. So let's create public delegate. So we have to use the delegate keyword. Then we say what type we want to return. So for now, let's say void. Now we give it a name. So we name our type. So that's rect action. It can be whatever, right? And now we give it what parameters it will require. So vector 3 int. and it will require coordinates. So basically that means that we'll want to have a method to which we'll pass the specific coordinates, and then this method has to describe what should happen at those coordinates. Now that means that over here we can grab the parameter, so rect action, let's call it action, and over here you see we can treat it as a regular method. So under this name there's method, so we can simply invoke it, but over here we said we require a parameter, so over here we have to pass that parameter, and for us it will be coordinates, so the starting point on the cell plus new vector free int, and then x, y, and 0. So basically what we do to the starting coordinates, which will be passing over here, we'll be adding new position of this and this. So basically this action, which will be called for every single position in the rect. Okay, so now just to make it a little bit clearer, I hope, I can just for a sake of explanation, just create a method, void xxx, this doesn't matter, and then create another one, which will return void, because our delegate is of type void. Let's call it do something, doesn't matter. And now it has to have the parameter of type vector free int, because that's what we require over here. Over here we also can name it whatever we want, so tralalalala. Let's say this doesn't do anything else than debugging this tralalalala. Awesome. So this is our special method, and how we would use the extension method and the delegate now. So I have, let's say, some rect. This could be any RectInt. It could come from somewhere like our custom collision space that we'll have on our buildables. And now you see this rect has iterate method, and this iterate method, you see this straight away started to be highlighted. So if we don't have that, this is unused. If we call iterate, this is highlighted because we are using it. So this is literally our custom method that is added to the RectInt. So you see, I'm not providing the rect as a parameter. So this is literally this part, right? And now it requires me to pass two parameters. If we have a look over here, we have those chords and action. So the chords could be any, again, vector free int. So this could come again from the position of our cell in the grid. And now I have to provide, you see, delegate. So I can create a method. So I could literally just do something like x and do some actions. So I don't know, again, debug log x, right? So this will work too. Or I can simply pass here a method that matches this delegate type. So it has to be void, and it has to have the same parameters. So I grab this, I grab this do something and just put it here. And what will happen, this rect is terrible example because it doesn't have coordinates, but let's say it has some coordinates. So what will happen, it will iterate through all of the positions, it will add it to the vector 0, 0, 0 that we passed here, and at the end it will literally pass this combination of the chords that we passed and x and y that are in the current iteration, and then basically will at this place just call do something with this parameter. So I hope this is clear. So now we'll need another variation of that, which will return a type. So delegate that returns boolean. So now it cannot have the same name, so I'm going to change it to rect action bool. It will require the same parameter, and we need very similar extension method. So let's grab that over here, and now instead of requiring the rect action, let's use the rect action bool. So you see, we want to do some stuff with it. Basically, if the action that we provide, you will see what we do later. So we'll be using that in, I think, 2 places. So you will see exact use case for that in a second. Just when we are here, I just would prefer to be done with that. And if this is a little bit hard part for you, then you can just use it and forget about it. And then one day when you feel more confident, just come back to that and then have a look. And I'm sure sooner or later you will understand that. Just bear in mind, if you don't understand it, don't worry at all, because both of those things are pretty advanced concepts. So this is not something that, you know, you do on the first year of university or something like that. This is a little bit hard stuff. So first we check if the result of this action that we pass here is true. And if so, we return true. Then when the looping finishes, this should also return Boolean over here. Then when the looping finishes, so over here, we return false. So what it does, basically we start iterating through all the positions like previously. And if this method returns true for any of the coordinates, so any, even the first one, right, we return true. Otherwise, if none of those coordinates resulted in this action returning true, we will return false. Let me just give you an example that we'll be implementing in a moment. So let's say over here we have an action that checks if the position on the tile is occupied, right? So we check, is the first space occupied? No. Okay, let's go to the next position. Is the next position occupied? No, it is not. Let's go again. Is the third position occupied? Yes, it is. Return true. So now we know that there is any occupied space on the rect that we are checking. If we would loop through all and none of them would return true, that would mean everything is empty. So no, it's not occupied. I hope this is clear. If not, don't worry, as I say, you can use it and still benefit from it. Sooner or later, you will understand it. Trust me, this is really advanced, but once you understand it, it's really, really fun to use. Okay, so now let's finally use it. Let's go to our buildable. We'll be creating now two methods, which will iterate through the collision space that we added to our buildable item. User of those methods will be able to pass the methods that should execute for each coordinate, but will not have to specify the position or anything like that, because we already have it stored as a part of buildable. So public void method iterate collision space, and now RectInt extensions, and then first let's use this one. So, and for that now we can use the buildable type. So this is our buildable item, and it has the collision space. So collision space. So that's our RectInt, and now it has the iterate method. And of course it requires us to provide those two parameters. So first one are the coordinates, which we already have also stored on the buildable itself, so we can do that. And now we just pass the action. So you see, we add extra level of abstraction, so somebody doesn't have to know what is happening under the hood. They will be able to just use this method, and it will be much easier for them. Now let's just create another one. Let's copy paste this one, and let's make it return bool, because we have our another version of that method, right? So over here, let's just add bool, and let's return that. So this is all we had to do. Amazing. So as you remember, probably we created extra layer, which is the collision layer. So let's now create a script for it. I'm going to the building system folder and creating new script, and I'm calling it collision layer. Now I'm assigning the script to that layer and then opening it. So moving it to the right, namespace, closing that. Now, of course, we wanted to be extending our tilemap layer. Awesome. Basically, what we'll be doing here, whenever some item has the custom collision space, so should occupy certain grid cells, we'll be placing there our squared tile. So first we need the reference to that tile base. So serialize field, private tile base, collision tile base. Awesome. Now we're importing the missing reference, which is the Unity engine.tilemaps. And now let's create a method which will actually handle that for us. So we'll actually place those tiles. So public void set collisions. And now we want to mention for which buildable, right? Buildable. And then the second parameter is value. So if we pass true, we want to set the collisions. If we pass false, we want to unset the collisions. So we want to clear them when we destroy the object. Let's now import our namespace. So building system.models. And over here, first, we check which tile we should set, right? So if value is true, then we're going to use our collision tile base. Otherwise, we're going to use null, which will clear the grid cell. And now we can use this beautiful method that we added on the buildable. So buildable, iterate collision space, and now for certain tile coordinates, because it will loop through all the coordinates, what we want to do, we want to simply on the tile map, set the tile, add those coordinates that come over here. We'll have a look at that in a second. We want to set the tile which we selected over here. So now let me run you quickly through what will happen. So somebody calls the set collisions, passing a buildable at certain coordinates with, let's say, space 2 by 2, right? Passing over here true. We select the right tile, so we want to set it. And now on that buildable, we have our method to which we pass a method. This over here. So this is equivalent to public void do xxx, because the name doesn't matter here, right? Because when we use the arrow functions, it's like anonymous function, so it doesn't have a name. Then it has the parameter, which is the vector3 int chords. And now we literally just do that. And we have access to the tile, right? Because we are in the context of, so we pass it inside this method, right? So we kind of have it, let's say over here, right? Now we don't have value, but I hope you get the point. So we have access to that because this is part of the same method. So we have the variable over here. So those are equivalent. So what will happen? This method will not be executed here, but it will be passed to that method. Then you see we can do that because we use our delegate. What will happen? This method will be passed to our collision space iterate. And that's this action, and the coordinates will be those ones from the buildable object. So what will happen then? We go one layer, like one level deeper. So we go into iterate. And now for that collision space, at those coordinates that we passed over there, we'll iterate through each single X position and each single Y position. And then for those, again, here we pass our method. So over here, we'll execute that method with this parameter. So at the end, at this level, this action over here will be exactly the same thing as the this method. So literally this is what will happen. So we'll pass those coordinates over here, right? This will be passed over here. And then the tilemap set tile will be at those coordinates. So I hope this makes it a little bit clearer. Okay, so we have that. Now that means in our construction layer, we have to have the reference to our beautiful collision layer. So serialize field, private, collision layer, collision layer. Awesome. We'll set that for the inspector. And now, I'm not sure you remember, on our buildable item, besides the collision space, we added also the use custom collision space flag. So let's use that to determine if we should be using it or not. So over here, after we have the buildable, let's just check if the item, if for that particular item, we should use the custom collision space. So that is inside our build method, just for the clarity. We check if we should use the custom collision space. And if so, then on our collision layer, we should set collisions for that buildable that we created over here, right? And then of course we want to set it to true. But this is not all, because this will set the collisions, but we'll be still able to build all those positions, right? Because we have two separate tile maps, right? So this one, construction layer, where we place the tile buildings, and then collision layer. And then on top of that, on the construction layer, we have the script, the construction layer, which has this buildables dictionary. So we also have to make sure that all of those positions are registered over here with the same buildable. So let's create a method for that. And here we'll be using our beautiful extension methods. So over here, let's create a method. So let's make it private void. Let's call it register buildable collision space. And now we pass the buildable. Awesome. Now on the buildable, we use the iterate collision space method, which we created. And over here, we simply, again, for specific tiles coordinates, what we want to do, we want to add those coordinates to the buildables dictionary, where the key will be those tile coordinates and the value will be buildable. So this will literally for each position place the same buildable in our dictionary. Let's put it over here so that we pass buildable. This method will also register the regular coordinates because that's where the looping will start. So there is no sense to actually call this one if we already called this one. So let's here just give else and let's move it over here. Awesome. Okay, so let's test it. So first we have to add the collider to our collision layer. So let's add the composite collider, which also added the rigid body. So let's make sure that the body type is set to static. And then let's also add the tilemap collider 2D. On the tilemap collider, we have to make sure that the used by composite checkbox is checked. Awesome. So we have that. Now our collision layer has this collision tile base reference. So we have to fill that too. So let's go to tilemap, buildables, and let's drag the collision rect over here. And then of course on our construction layer, now we also have to fill the collision layer reference. So let's just drag and drop the collision layer. And then of course we need a scriptable which will have the custom collision space. So first we check the checkbox to use the custom collision space. And now for sake of testing, let's set the width to 2 and height to 2. And now let's have a look at our mannequin. So we placed it and we see all of the grid cells were occupied. So this is exactly what we wanted. But now we have a small problem. So if we try to build something on any of those cells, this will not work. So this is correct, exactly what we want. But if this item takes those four cells, right, we shouldn't be able to build another one, for example, here. So if I try, I can do that. Then I, of course, have the error that this place is already occupied by another item. So this is a little bit problematic and we'll have to fix that now. So first, let's make the collision layer a little bit less visible. So this is pretty simple. On the tilemap, we can simply change the color to very low alpha, something like that. So now, just for the sake of testing, we can still see that. So this is perfect. I'm not sure you can see that because it's really, really light. But then if you wouldn't like to see it, you can simply on the collision layer, disable the Tilemap renderer, and what will happen, you won't be able to see the tiles, but they will be still there and the collisions will be applied as expected. So this is pretty neat. In case you want to see them again, you just enable it and you see those, and it's very easy to debug. Okay, so let's now extend the isEmpty check. So I'm going to our code over here, and at the very end, let's add in the construction layer extra method to check if a specific rect or set of cells is not occupied. For that, let's create private bool is rect occupied vector free int coords. So we want to check starting at those coordinates, right? Then, of course, the rect itself. So let's call it rect. And now simply we first take our rect and iterate through all the positions on it using our extension method. It requires us to provide the coordinates, and also it requires us to provide the method. So tile coords, so at given tile coordinates, check if the buildable contain those tile coordinates. And of course, we want to return the result. So over here, we are using, if we have a look at our RectInt extension, this method and this delegate. So we are not using the first ones, right? We are using those that return bool. That means that for each position in that rect that we passed, we simply check if it's true or not. So if buildables contain certain coordinates, what will happen? We'll return true. And that will mean that in a given rect, at least one rect is occupied. At least one cell is occupied. So this means this space is not available for building. As simple as that. So we go to the construction layer and let's now use the isRect occupied. We can do it in our isEmpty method. So at this moment it takes only the word coordinates. So let's add another parameter. Let's call it RectInt collision space. Now we want to default it to something because what will happen? We already use the isEmpty in several places, I think, and basically this would break the code. We would have to go there and fix it, and this way the other places do not have to stay untouched unless we have to change them for other reasons. And now, normally, if the RectInt would be class, we could simply default it to null. But as I mentioned briefly before, this is a structure and it has different default value. Just to make sure that this is the correct default value, we even don't have to do the new RectInt, but we could also just do default. So the .NET framework will just put there the type that we should use. Over here, after we get the coordinates translated to the cell space, we can first check if our collision space that we provided is not equal, so not equals to the default value, so default. And if it's not, that means we have provided different collision space than the empty rect, so the 0000 rect. In that case, we want to check if our rect is not occupied. So is rect occupied at those coordinates at given collision space. And of course, we need to return it. Okay, so now let's use it in our building placer. So we have our building placer. Okay, so now let's modify this, this method call over here. So we check always if it's empty at given mouse position, but we never take into consideration the collision space. So for that, let's just check if the active buildable should use the custom collision space. And if so, let me just move it to the next line. And if so, then let's use the active buildable collision space. Otherwise, let's use default. So that should do it. And now let's give it quick test. And yes, I cannot build, but we still have a problem with preview. Over here I should be able to build, over here yes, but here not. Okay, so let's fix the preview now. So where do we set our preview? Over here. And we see that this will expect exactly the same condition as this one. So let's just grab it and maybe let's store it in a variable over here. So var is space empty, and then use that over here. Then let's just clean that a little bit. Awesome. And now instead of using the methods, we can use our variable. And now everything should be working fine. So perfecto. Yay! All working as expected. Just now, I'm pretty annoyed about the size of the collider on the mannequin, so let's just change it to the width 1, and this should be a little bit more realistic. Okay, so we cannot build here, but we can build over here. Awesome. So we can do that. We cannot place it just one behind, so this is how we designed it. Awesome. And everything works here as expected. So now the only thing that's left for us to handle is destroying those items, because currently we don't remove the items from the buildables correctly. So we only remove the origin position, and we also don't remove the items from the collision layer. And that will conclude the tutorial. Okay, so let's get back to our construction layer. Over here somewhere we have the destroy method. Great. So let's make it handle also the other scenario. So we have buildable over here. So we already have the information if it should be using the custom space or not. So if buildable type, use custom collision space. So if it uses, then of course we have already a method on our collision layer. So collision layer set collisions for that buildable to false, right? So this is handled. So this will remove the collisions from the collision layer, but now we don't have anything to remove the tile coordinates from the buildables list. So we have to clean those spaces too. So maybe for this, let's just create another method and call it unregister. So it will be as simple as removing buildables from here and then changing add to remove. Now we have to be careful because the remove method returns bool, and that results in using the wrong delegate and wrong iterating method. So it would actually, after removing the first item, it would actually stop the execution, because if you remember, in our extensions, once the method is evaluated to true, we stop the execution. So in order to prevent the method from doing that, we simply surround it with the braces and make sure there is no return statement. And this way we are safe and everything will be working as expected. So now let's just grab the unregistered buildable collision space and put it in the destroy method over here. So for buildable and semicolon. And this should be it. So let's test it out. So first maybe let me change the collision space color a little bit, so it's a little bit more visible. And now let's test it. So for this one, nothing changed, so there shouldn't be any problem. Yes, I can build place. Now you see I occupied those two places. I cannot take any of them. If I remove it, both spaces are available also for other items. So now I cannot place it here as well correctly, because the collision space is equal to 2 spaces. So that's 2 cells. So this is what we expected. So at this moment we are able to do literally everything. So we can just disable the tilemap renderer on collision layer and now have fun with our building system. So let's just maybe create some small training grounds or something like that. Yay. Awesome. So this is great. I really love it. I was very excited to be able to create this system for you. And I hope you learned something useful. As mentioned before, I would really appreciate if you like this video, subscribe to my channel and leave a comment, because then there is a huge chance that the algorithm gods will be pleased and they will basically propose this video to other people, and maybe they will learn something useful too. And of course, have a fantastic day, love you, and bye bye.